So here we've got a cuboid. We're given areas of 3 of the faces, but we're not given the actual lengths of the sides. And we're told that we want to melt it and make new cubes. Right, so before we can do that, we need to work out the volume of this solid metal cube, which we can't do until we know the sides. So let's label them and see what we can come up with. So if I call this side X, this side Y, and say this side Z, I can see that X times Y equals 45, because that's how you'd work out the area of that. X times Z is 27, and Z times Y, so YZ is 15. And what we need to be able to do is work out how to get those numbers using each of those. Now, you might be able to see it, and you might be able to see that your X's, you could do 5 times 9 to give you 45, and that would be 3 times 9 and 3 times 5. If you don't see it, also not a problem at all. You could have rearrange one of these equations or divide them by each other and be able to work out a process to do that. They're going to not make it too tricky. So if I have a look here, I'm going to start off by saying 9 times 5 gives me 45. So now I've said like X is 9. So if I have 9 times something, gives me 27. So 9 times 3, well, that gives me 27. So that works. And I just want to check that 5 times 3 is 15. So I now have each of my sides. In order to work out the volume of this whole big thing, I now have to do 3 times 5 times 9, which is going to give me 135. So now I've got a cube. Cubes all have the same lengths. So the volume of each cube is going to be 2.5 cubed, right? So it's going to be 2.5 times 2.5 times 2.5, which is the calculator paper, so 16.625. Now, if I take my 135, the volume of the whole thing, divide it by 15.625, I get 8.64, so on. I want the greatest number of cubes, so I can't get more than 8, so it would be 8 cubes could be made.